Let's go to LeetCode 2608. Shortest cycle in our graph. For this question, they give us a graph which is a two-dimensional array and also n vertex. It lets us to detect the shortest cycle in the graph. So the hard point is that this is a bidirectional graph. So what we think about is that for bidirectional graph, if we have node A and B, right? This is not a cycle, but in directed graph, A goes to B, B goes to A. This is a cycle with size 2. So for this question, we'll say A, B, C, right? So at least the 3 nodes connect together that will form our graph. We're going to use an int array called distance. And let's build distance -1. For bidirectional array, we don't need to use the weighted array 0, 1, 2 again, right? Actually, we can use this distance if it is distance I equals -1, then that is not visited. So int I equals 0, I smaller than n, I plus plus. Let's say if weighted I equals -1, then we do DFS something, right? From this edge, because it's bidirectional, let's compose from the edge to compose the map first. Map integer, list of integer, graph, new hash map. And for this edge in edges, I have a graph compute if absent. Edge 0. Take goes to new array list. Add each 1. And also we have another direction that is H1 as key and H0 as put into its chart. So what we need is at least we need this graph, right? And we need I. And for bidirectional array, it's better we pass something called parent, because we are going to iterate its child. But if this child, if it equals its parent, we are going to continue. And we need a distance array, right? So here, if this equals 0, we have set this distance I equals 0. If it is, we don't have visited, right? So if this distance equals -1, then we'll set a distance as 0. And we can have a result with new int 1. And the result 0 equals, we are finding the minimal circle. So we'll have integer of max value. And we have passed the result. And in the end, we just return if result 0 equals integer dot max value. That means we didn't detect a circle. will return -1, otherwise we return result 0. So to write a DFS here, we have private void DFS. We need to have this graph, and we need a current node that is I, and we need its parent, and we need the distance array, right? And let's put the result as to update the result. If we detect a circle, then we update the result. So the first thing is that for this kind of graph, possibly does not contain key, right? So if graph contains key, doesn't contain key I, we just return. Then for int next in graph with I, right? So the first thing is that this next can be its parent. So if next equals parent, we are going to continue. And the next thing is that if distance next equals -1, that means for next node we haven't bid, or distance next greater than distance I plus 1, right? So that means we find a shorter route. Then we're going to have distance next equals distance I plus 1, and the DFS graph next I, and the distance and the result. And also we'll write if distance next smaller than distance I plus 1, right? So for directional graph, this means this will be a circle. But for bidirectional, this may not necessary, right? So because it is possible only there is 3 nodes, at least 3 nodes next, right? And he go this way, then go this way, then go this way. Then if DFS like this, will form a circle, right? But if post DFS, we go to this node first because there is a bridge between I and next. Then we still have distance I plus 1 greater than the next. For example, the next equals I, right? So it is possible next equals to I. So we'll say in order for bidirectional array, in order to form a graph, a circle, we needed to have distance next smaller distance I. In this case, we'll have the circle size. Circle size will be distance I plus 1, still distance I plus 1 minus distance max. So we can update the result 0 equals max dot min result 0 distance I plus 1 minus distance next. This will be the DFS way to this question. Parent. So for the initial one, we set a -1 for the parent.